Miss Collier explains.
Line graphs.
A learning intention is to understand that a line graph can be used to display continuous numerical data, to be able to draw a line graph, to use that line graph to estimate values, and be able to interpret a travel graph. We will know we are successful when we can both draw and interpret line graphs. Today we're going to look at line graphs. Line graphs in everyday life. A business can use line graphs to display data such as expenses, sales, profits over a period of time. A line graph makes it easy to visualize trends and make predictions. So, a line graph consists of a series of points joined by straight lines. A line graph is used when both axes are continuous numerical data. Because both variables are continuous numerical, we often show time on the x-axis. A common type of line graph is a travel graph. In these graphs, time is shown on the x-axis and distance is shown on the y. The slope of the lines indicate the rate at which distance is changing over time, or we might know it more commonly as speed. The steeper the slope of the line, the faster they are going. Let's practice drawing line graphs. The question says, the temperature in a room is noted at hourly intervals. Present it in a line graph and make a prediction. We're going to switch views and draw a line graph. When creating a line graph, just like any graph, the first step is to rule up the axes. Next, I want to figure out my measurements for my axes. A line graph consists of two sets of continuous numerical data. So we usually put time along the x-axis. We start our first time right up here on the y-axis, which mine is 9 a.m. I now need to check that all the intervals are the same, and I can see that it's every hour, and I've got 5 hours. Seeing as I've got a bit of space, I'm going to put each hour 4 lines away from each other. And I'm going to label this axis time. Now my y-axis is temperature. My highest temperature is 23, but I want to go above that. I have a lot of room. I have more than 25 blocks, so I'm going to do each block is 1 degree. I don't want to write in every number up the y-axis, so I'm going to write in every fifth. And I'm going to label my axes temperature. And put the units in brackets, degrees Celsius. Now that my axes are drawn up, I can input my data. I'm going to start with 9 a.m. At 9 a.m., the temperature was 10, so I'm going up to the 10 and I'm doing a dot. These should be on intersecting lines to make it easier for you. 10 a.m., the temperature was 15. I'm going up to the 15. 11 a.m. was 20, following it up to the 20. 12 was 23. I'm following it up to the 20 and I'm going 1, 2, 3. And 1 p.m. was 18. I'm going to go up to the 20 and then go back to 19, 18. Once I've put dots where all my data is, I then need to connect them with lines. That is why it's called a line graph. So I'm going to connect each dot up with a line using my ruler. The reason that we use lines is because the temperature didn't jump straight from 10 to 15 immediately. It would have risen slowly over the hour that it took. So this line represents that rise. I'm now almost finished my graph. The only thing I need to do is add a title, which I'm going to call it room temperature. Now I'm done. B says, use your graph to estimate the room temperature at 12:30 p.m. Now that is why lines are also really useful. We can see the slope, which is the rise or the fall that is happening, and we can use that to make estimates about data that we don't know. So to estimate 12:30, I'm going to go halfway between 12 and 1, and that's this line right here. I'm then going to follow that line all the way up until I reach my data line up the top. I have hit this point right here, which I'm going to round down to here, which is 20 degrees. So I think it's probably approximately 20 degrees at 12:30. Now you try draw a line graph. Let's quickly check our answers. First step, draw up your axes. Next step, put your measurements in. My first time is 4 p.m. I'm going to do every hour 4 along. My y-axis is temperature. My highest is 30, but my lowest is only 15. So I'm going to start my 15 out here, and I'm going to use my break symbol to show that there's a break between the 0 and the 15. Now I'm going to count out every 5 and then write in every 5th value. I need to label my axes, and I'm going to say time and temperature with Celsius in the brackets. Now that I've drawn my axes, I can put in my values. 4 p.m. was 25. 5 p.m. is 30. 6 p.m. is 20. 7 p.m. is 18. I'm going to go up to the 20 and back 2. And 8 p.m. is 15. Now that I've drawn in all my dots, I'm going to connect them with lines, using a ruler obviously. Now my graph is finished, it just needs a title. And this was the temperature outside, so I'm going to write outside temperature. My line graph is finished. But B says, use your graph to estimate the outside temperature at 5:30. 5:30 is halfway between 5 and 6, so I'm going to come to this line. I'm going to draw up my line to figure out an approximate value. And I think it is 25 degrees. So at 5:30, I think it is about 25 degrees. Let's try interpreting travel graphs. This travel graph shows the distance traveled by a cyclist over 5 hours. A. How far did the cyclist travel in total? Well, the total would be the end of their journey at the 5-hour trip, and this point is at 30 kilometers. So they must have traveled 30 kilometers altogether. B. How far did the cyclist travel in the first hour? I'm going to go to the time of 1 hour and look at this dot, which is 15. So they traveled 15 kilometers in the first hour. C. What is happening in the second hour? Well, between 1 and 2, we can see that the slope is flat and the distance does not increase. So our cyclist must have been having a rest. We can tell this because no distance is gained during that hour. When is the cyclist traveling the fastest? Well, the steeper the slope, the faster they are going. The first slope is 1 hour for 15 kilometers. The second slope is from 2 to 5, which is 3 hours for another 15. So the first hour is when they were traveling the fastest because that's the steepest slope. E. In the 5th hour, how far did the cyclist travel? Well, I'm going from 4 to 5. So the 4th point is at 25 kilometers and then he finishes at 30 kilometers, which means he must have traveled 5 kilometers in the last hour. You try interpret a line graph. Let's quickly check your answers. This travel graph shows the distance traveled by a hiker over 4 hours. How far did the hiker travel in total? I need to go to the end of the trip, 4 hours, and that dot is on 10. So 10 kilometers is the total distance. B. How far did the hiker travel in the first hour? The first hour, on the number 1, I go up, and that is 5. So 5 kilometers from 0 to 1 hours. So 5 kilometers in the first hour. C. When is the hiker stationary? Stationary means staying still, having a rest. I see that my graph is flat between 2 and 3, so that's in the 3rd hour. My hiker must have been taking a rest in the 3rd hour. D. When is the hiker traveling the fastest? I have 3 slopes here. In the first hour, 1 hour, 5 kilometers. The second hour is 1 hour for 2 kilometers. that's not as fast. The last slope is between 3 and 4, and that's 3 kilometers, meaning the first hour was the fastest travel time. And E, how far was traveled in the fourth hour? Between 3 and 4, we go from 7 to 10. So that is 3 kilometers in the fourth hour. I hope now you can see how to draw a line graph and interpret a travel graph.